Every time we make a choice or a decision, a parallel universe is born. This is a concept based on the famous many worlds interpretation (MWI) theory by physicist Hugh Everett III. There is a TV series based on the many worlds interpretation (MWI). That series is Dark Matter. The main concept of this series isn't simple time travel, but is based on the many worlds interpretation of quantum mechanics. The entire story is driven by an invention called the box. This is a device that allows a person to travel to parallel worlds. It's not as simple as opening a door and walking through. A person must enter the box and inject a special drug. This drug puts the brain into a state of superposition, the quantum state of being in all possible places at once. At that moment, the person in the box experiences being in an endless corridor in their mind. This corridor has countless doors. These worlds are born from our choices. According to the many worlds concept, every time you make a decision, e.g., turn left or turn right, the universe splits in two. In one world, you turned left. In another parallel world, you turned right. Both of those worlds truly exist. The box is what allows travel to these possible worlds. 1. What-if worlds. The protagonist of the story, Jason Desson, had to make many decisions. Jason 1, the original protagonist, he chose to stay with his girlfriend Daniela and build a family. He became an ordinary college professor. Jason 2, Jason from another world, he chose to leave Daniela and focus on his scientific work. He became a highly successful physicist and invented the box. The story begins when Jason 2, desiring Jason 1's happy family life, uses the box to swap worlds with him. 2. How is a world chosen? While in the box's corridor, you must focus intensely on the world you want to reach, or the decision you made. The memory or decision you focus on opens the corresponding door and allows you to enter that world. 3. The danger. The problem is that the number of worlds is infinite. The protagonist, Jason 1, while trying to return to his original family's world, ends up in many wrong worlds. Some worlds are ravaged by pandemics. Some worlds are covered in ice. Some worlds are almost identical to his original world, but small details like the paint color on a wall are different. In Dark Matter, the parallel worlds are the real, tangible worlds born from every road not taken in our lives. The box is simply the key that unlocks the door to those what-if scenarios. Let's continue by explaining what is the many worlds interpretation, MWI. Simply put, MWI is a theory that proposes every time a quantum-level probability occurs, the entire universe splits to allow all possibilities to become reality. Every time you make a decision, or a quantum particle chooses a path, new worlds branch off. In every one of those worlds, a different outcome truly happened. This idea was first proposed in 1957 by physicist Hugh Everett III in his PhD thesis, Relative State Formulation, and later named Many Worlds by Bryce DeWitt. Why did this idea emerge? To understand this, we first need to know the original problem MWI tries to solve. That is the problem of the original quantum theory, called the Copenhagen interpretation. 1. The Copenhagen interpretation, the original theory. Before a quantum particle, like an electron, is observed, it doesn't have a precise location. It exists as a wave function of probabilities, being in all places at once. This is called superposition. Only when we measure or observe it does this wave collapse and the particle appears in a single location. The problem: what is a measurement? Does it require a human to look, camera? No one could explain why this collapse happens. 2. How the many worlds interpretation, MWI, solves it. Hugh Everett boldly proposed there is no collapse. He said, when a measurement happens, the wave function doesn't collapse. The universe itself splits. Possibility A happens in one world. Possibility B happens in a new separate world. The observer, being part of the quantum system, also splits in two. Cat, the easiest example. Let's explain using the legendary Schrödinger's cat thought experiment. The experiment: a cat is in a box. Inside is a device that will break a vial of poison based on the decay of a quantum particle. The probability of the particle decaying is 50%, and 50% not. We will open the box in 1 hour. How Copenhagen, the original theory, explains it. Until you open the box, the cat is in a superposition. This means it is both alive and dead at the same time. Only at the moment you measure or open the box does the wave function collapse, and the cat becomes either alive or dead. How many worlds MWI explains it. No measurement is needed. The instant the quantum particle makes its decision to decay or not decay, the universe splits in two. World A, the particle decays. The poison is released, and the cat dies. You, the version of you in this world, open the box and find a dead cat. World B, the particle does not decay. The cat lives. You, another version of you in this world, open the box and find a living cat. According to MWI, both the alive cat and the dead cat are real. They just exist separately in two different branched worlds. Mechanism, the splitting mechanism. In the past, this was simply called splitting. But in modern MWI, this process is explained by a mechanism called quantum decoherence. What is decoherence? When a quantum system, e.g., the cat, interacts with its environment, e.g., air particles, photons, its quantum probability waves lose their connection to each other and become separate. To explain, as soon as the alive cat wave and the dead cat wave interact with the environment, they fall out of sync and become two paths that can no longer communicate or affect each other. Therefore, it's more accurate to say the worlds lose contact or can no longer interfere rather than physically splitting apart. Joyce's major arguments and support. What supporters like. Mathematical purity. MWI requires no changes to the original quantum math, the Schrödinger equation. You just trust the math, and the many worlds outcome emerges naturally. 2. No observer problem. There is no need to define the strange act of measurement. The observer, the cat, and the particle are all just things following the same quantum rules. What critics dislike. Violates Occam's razor. This principle states, the simplest explanation is most likely the correct one. Critics argue, inventing infinite, unseeable universes just to explain one tiny particle is not simple at all. It's incredibly complex. Supporters counter that many worlds is simpler because it requires fewer rules. 2. The probability problem. This is the biggest issue. If MWI says all 100% possibilities actually happen, then why do we still say this particle has a 50% chance of decaying? You can't talk about probability if everything happens. There are theories that try to solve this, but it remains controversial. Universes. Unfalsifiable. There is no way to test if this theory is true or false. We cannot travel to or communicate with these other worlds. So critics argue it's closer to philosophy than science. The many worlds interpretation, MWI, is the idea that probability doesn't exist, only actuality. Every time you encounter a quantum crossroad, The universe branches to follow all paths, and in each of those branches, a copy of you continues on its new path. Although currently unprovable, it remains a mathematically beautiful and compelling solution to the measurement problem of quantum mechanics. Thank you very much for watching. Please subscribe to our channel to see more content about space science and technology.